Alrighty, hello everybody, welcome to topic 3. What we're going to be working with today is multi-step problems. So up to this point you've been working with a single triangle, and that single triangle you just had one side that was missing, or maybe two sides. Now we're going to be working with multiple triangles. The really big overarching idea is using what you have and working towards what you need. That should be your mindset going into here. Up top we have strategies, hints that we're going to also implement here as we go through the video. So here's our first problem. AB is equal to 115, so I'm going to label my picture. And we are trying to find the length of DC. The first suggestion that we have is labeling what we ultimately need to find with a variable. So DC, I'm going to label X. Then, the other things that you're going to want to look at are, okay, if I need to find this, what else will I need to find? Well, X, this DC, is a part of a bigger side of this triangle. And if you're having a hard time seeing those triangles, you should label the triangles like this. If I want to try to find X, that is a part of this larger side of this blue triangle. So I'm going to label this part BD. I'm going to label this Y because I do need to find this in order to find this. Because if I just focus on this triangle, ADC, that's not a right triangle, so I won't be able to work with that. So the next, one of the next steps, which is redrawing the two right triangles. So that will help you pull out the ideas and have them off to the side so that you can be a little bit more organized in what you're doing. So I'm going to draw both my triangles in the appropriate colors so that they match what I have up top. So this is ABD, this side is Y, this side is 115, and this angle is 56. For my blue triangle, we have this. We know the whole length of this side is X plus Y, because if this part is Y and this part is X, then altogether it's X plus Y. One of the other ideas that is going to be really important is seeing where the triangles overlap. If they have something in common, then we're going to end up being able to set different parts equal and make connections between our two triangles. So this side AB is going to end up becoming very important. Let me also draw on the right angle here. So, in order to find X, I'm going to need to find Y. So let's find Y. Looking at this green triangle and my diagram down here, which trig function will I be using? Since I know the opposite side and I want the adjacent side, I'm going to be using tangent. So tangent of 56 is equal to 115 over Y. So Y, after I plug it into my equation solver, I get to be 77.5685. I'm going to keep all my decimal places until the very end. Now, so since I know that that length right here is 77 point ... now I can use this and consider this whole side as one for my blue triangle. Ignore that. So, looking at my blue triangle, if I know this side and I want to find this side, which trig function will I use? Well, again, I know the opposite. I'm trying to find the adjacent. That's going to be tangent again. So tangent of 35 is equal to 115 over, sorry about that, 115 over X plus Y. but now I know that y is 77.5685. So that's going to be x plus 77.5685. I can plug this into my equation solver and get that x is equal to 86.6685. Normally, I should have written it here, round to the nearest hundredth. I forgot to do that. But here, let's do that. So it says round to the nearest hundredth, so x equals 86.67. There you have it. And that x, of course, is DC. So DC equals that. Again, overarching ideas, we find the overlapping side, we label what we want to know, and we work towards what we want to know with some middle steps. So let's take a look at another question. This one, we are trying to find the length of EG to the nearest hundredth. Finding the length of EG to the nearest hundredth. So, as of right now, I don't know any sides of this triangle, but I see that there's a right angle here, and a right angle here, and a measurement over here. This is, therefore, a rectangle. So, that means that this side over here must be 85 meters. Okay, so now I'm a little bit closer. And I can you see the two right triangles here? I'll label them. So even though there are 3 right triangles in this problem, this blue right triangle that I drew has an overlapping side with the green triangle, which has what I am trying to find. So that's why I'm using this triangle instead of this triangle. Now, I don't know any side lengths of this green triangle, but I know a side length of this blue triangle. So I want to find the side that both of those triangles share. Which trig function should I use for that? We should use tangent. I redrew my triangles down here, and I see that if this is my reference angle, then the side opposite is this side, and this is my adjacent side. So yet again, third time today, we're going to be using tangent. So tangent of 30 equals 85 over y. I plug that into my equation solver, and I get that y is equal to 147.2243. And I can either write that in this diagram, or this diagram. I'm going to just write it in this one. You can write it in all 3 if you'd like. 147.2243. Now I know a side and an angle for this green triangle, which allows me to find x. You're probably used to it by now, but this is the opposite side and the adjacent side. They're not all going to be tangent. Sorry. But tangent of 27 is going to be equal to x over 147. Plugging that into the equation solver, I get that x is equal to 75.01 because we're rounding to the nearest hundredth. And that is equal to EG. Okay, so again, the big idea is finding that mutual side, and then that will allow you to find the side that you're looking for. So final diagram here. We have the AE is parallel to CB. Parallel, your mind should automatically go to alternate interior angles. AC is 362. EAB is 33. And EAD, this big angle here, is 48. So how much is this angle? Well, 48 minus 33 is 15. Well, 33 isn't a part of a triangle, and 15 is, but it's not a part of, anything of substance. So you should be looking for alternate interior angles. So which angle is also equal to 33? That would be this angle down here. I'm looking for my Z shape. I see that this angle is also equal to 33. This bigger angle is 48, and I see that that Z shape means that this angle is also 48. Again, using my idea of alternate interior angles. So now I've labeled my diagram with everything that they gave me, and they're asking us for the length of DB. So I'm going to label that X. I'm also going to color my triangles and draw separate diagrams. There you have it. I've got my two right triangles. There are a bunch of different triangles here, but this is the right triangles. Labeled them, and I see that this piece here is X, but in order to find this piece, I need to know this whole side. So I'm also going to label this blue side Y, which means that this side is Y, which means that the whole side of this green triangle is X plus Y. So just like a couple problems ago, this triangle I know the most about, so that's where I'm going to start. I know that this is 48, 362, Y. A lot of tangent today, folks. So tangent of 48 is equal to 362 over Y. So Y is equal to 325.9463. Now that I know Y, I can get this side. So tangent for this second triangle. Again, not everyone is going to be tangent, but these ones are. 362 over X plus 325.9463. Plug that into my equation solver, and I get that X is equal to 231.4849. They didn't tell us what to round to, so we'll just leave it like that. Whoa. And that's pretty much all there is. There will be different problems that involve things other than tangent, like I said, but you find your two triangles, you create the other diagrams, you work with what you know, and you work towards what you want. It's the way it goes. It's the way it is. Have a nice day.